Welcome to EGBTech channel. Myself Ravi Kumar. Please subscribe our channel and share to your friends. In this video, I am discussing about the what are the equations and relations between voltage, current, and power in balanced delta system, or what is the relation between lines and phase relations in case of balanced delta network. For that, first of all, I am considering a balanced delta network, that is the delta network. We know that it is a formation of a single loop. We have considered all three impedances between three phases, all are equal. Okay. These impedances we are considering Z, Z, Z. Then here the formation of one node, that is the first phase R, and second phase Y. This is the second phase, and the third phase B. The three phase supply R, Y, B, which is connected to a delta system. Hence, we know the current passing through the line in delta network IR, IY, IB, or the delta IR, IY, IB are called the line currents, and the phase currents are the current passing between the phases, that is IRY, IYB, and IBR. These are called the phase currents. Similarly, we consider the phase currents among between the phases, that is between B and R. We are considering VBR. Between R and Y, consider VRY. Between Y and B, consider VYB. These are the three phase voltages. Then similarly, we know it is a loop. Then the current passing in the loop, you can take directions here. This current is coming from B to R. That's why we are consider IBR. This is from IRY. That is IRY. The direction from Y to Z. That's why the current we are considering IYB. Okay, IRY, IYB, and IBR are called the phase currents. IR, IY, IB are called the line currents. Okay, then we are clearly observing in delta network, that is all line voltages and all phase voltages are equal. Why? Because here there is no any neutral point. Okay, that's why in delta system, that is line voltage is equal to the phase voltage. That is line voltage is equal to phase voltage. In case of delta system, that is VRY, VYB, VBR equal to phase voltage considering, or we are considering line voltage also. Why? Because both are same. That's why all voltages are equal. So these are the voltage relations between the line and phase quantities in case of the delta system. In the similar manner, we have to find out what is the relation between the phase and line quantities of the current. Suppose consider the line current IL is nothing but IR equal to IY equal to IB. Similarly, the phase current, that is IPH, I suffix phase PH, equal to the currents are IRY equal to IYB equal to IBR. Okay, these are the phase currents in case of the delta system. Then after considering the line currents and phase currents, we have to derive the relations between the currents. Then clearly observe here in delta system, this is the node point. At this node point, IR current is entering, IBR is also entering, but IRY is leaving. That's why in delta system, we have three node points. That is point R, node Y, and node B. At each node, we have the three current directions. Then, first of all, we have to find out at one node. That means apply KCL at node R. Okay. Then that is what is the KCL? Sum of entering currents is equal to the sum of leaving currents. Then at node R, the entering currents are IR plus IBR equal to the leaving current are IRY. From that, the line current IR equal to IRY minus IBR. So this is consider equation 1. We know what are the IRY and IBR, all are the phase currents. That's why all currents are equal, but all are displaced by 120 degrees each other. That's why that is the first difference is IRY, that is phase current at an angle 0. The second one is IYB, that is IPH displaced at 120 degrees. Similarly, the third one IBR, that is IPH at an angle 240 degrees from IRY. Okay. Then you can replace these values in equation 1. From that, therefore, IR equal to, that is IRY. IRY value is IPH at an angle 0 minus IBR, that is IPH at an angle 240 degrees. Then all polar values you can convert it into equivalent rectangular form. Then this is the rectangular form for 0 degrees, IPH plus J0 minus, for minus 240 degrees, the rectangular form is minus 0.5 IPH plus J.866 IPH. You can see the equivalent rectangular forms. Then you can simplify the equations here. The real terms are IPH and minus minus plus 0.5 IPH. That is, IPH will be common 1 plus 0.5, that is 1.5 IPH, then minus J 0.866 IPH. Then IPH will be common IPH will be common. The rectangular form is 1.5 minus j 0.866. Then you can convert this form, that is IR. We know IR nothing but line current, that equal to, we can change into polar form, that is root 3 IPH at an angle minus 30 degrees. So this is the equivalent polar form for the 1.5 minus 0.866. Then clearly observe here, that means in case of delta system, that is all line currents is equal to root 3 into phase current. Okay, that means same in the same manner, IY equal to root 3 into IPH at an angle minus 30, IB equal to root 3 into IPH at an angle minus 30 degrees. Okay, like that, you can derive in case of delta system, the line current is equal to the root 3 times the phase currents. And also line voltage equal to the phase voltage. So these are the voltage and current relations between the line and phase values in case of delta system. Then after we know the values of voltage and current, then we have to find out the values of powers also. That means what is the power? First power, that is real power, nothing but active power. We know the formula V I cos phi. So this is the three-phase system. That's why in each phase we have the voltage Vi cos phi. In three phases we have the voltage 3 into Vi cos phi. By default, the voltage and currents are phase values. But in case of delta system, we know Vph equal to VL and IPH equal to, that is phase current equal to line current by root 3 into cos phi. Hence root 3 times will be cancelled. Then active power P equal to root 3 into VL IL cos phi. Okay, in case of line values, the power value. In case of phase values, the power is 3 into VI cos phi. In the same manner, what is the reactive power? Reactive power, it is denoted by Q. The same, the formula is root 3 into VL IL sin phi. Same another power, apparent power, it is denoted by S. Then in case of root 3 into VL IL. Okay, all these powers in case of line values. But in case of phase values, 3 into Vi cos phi. And reactive power 3 into Vi sin phi. And apparent power 3 into Vi, 3 into Vi. Simply, that is the apparent power. Okay, then by using these formulas, you have to calculate all three powers in case of three-phase system. Hence, after finding the all values in case of delta system, you must draw the phasor diagram of three-phase delta system. Okay, in case of derivative part, you must draw the phasor diagram also. So that means what are the phase voltages we have? That is all voltages are 120 degrees to each other. This place, that is V RY, V YB, V B R. Okay, all are displaced by 120 degrees to each other. Then we can draw this current here. That means between VRY and VYB, that means the line currents are, we are consider IR. Then we know the IR value. That means IR can be formed with, that is IRY minus IBR. Then by using vector sum of these two currents, we will get the IR value. But we know the phase angles. We have considered between the current values and the voltage values, the phase angle is phi, and between the, we know from the relation, the phase angle between the line currents and phase currents is 30 degrees. Okay. Then draw the second current value, that is IY. For IY, suppose this is consider IY current, then IY current can be formed between IRY, then opposite vector of IRY, and similarly IYB. Okay, this is IYB, this is minus IRY, that is minus IRY. Then vector sum of these two currents, we will get the current IY. Then similarly, we can draw the next current, the last current is, that is IB. Then the IB current can be formed, the IRY can be drawn in opposite side, that is minus IYB, and another current is combination IBR. Then the vector sum of these two currents, we will get IYB. Okay, then same between the line currents and phase currents, the value of the phase angle is 30 degrees. So between the voltage and current, the phase angle is phi. Then like that, we can draw the phasor diagram in case of star as well as in case of delta also. Then in case of problems also, suppose in case of problems, the value of, suppose consider balanced system, we consider balanced system, that is balanced network you have considered. Suppose in some problem we require to convert delta network into the star network, then the formula to convert from one form to another form, that is we have to find out the equivalent impedance of star network is equal to the 1 by 3 times of equivalent impedance value of delta. That means in delta value, every each value you can divide by 3, then you will get the equivalent star value. And also suppose we required delta impedance value, then you have to multiply 3 times with star impedance value. So these are the conversion from star to delta in case of balanced system only. For unbalanced system, we can use the same formula as in case of the DC network, where we have resistance only, that is star and delta. What are the formulas we can use to convert from star to delta? Same formulas we can use in case of impedance also. That is, three phase unbalanced star is converted into three phase unbalanced delta network. But these two formulas are we can use for only balanced network. These two formulas are very important in case of gate examinations also. Simply one of the network values are given, you can find out the another network values. Suppose star is given, we have to find out delta values. If delta is given, we have to find out the star values. Okay, na? And also in problems also, suppose Z value is given in case of balance, Z value is given, and also phase voltages or line voltages are also given. Then you have to find out the current by using formula in each branch or in each line or in each phase. Then I equal to V by Z. Okay, here Z values are equal in all phase, but here changes is the phase voltages. Between two phase voltages, the voltage value will be changes. Like that, we have to find out the current passing through each phase or each line in case of the balanced system also, or in case of unbalanced systems also. In case of unbalanced system, Z1 value, Z2 value, Z3 values are given. That is in case of unbalanced system. Then we have to find out I1 value, that is V1 by Z1. In case of rectangular, so remember, in case of problem, you are compulsory find out the all values in both forms, either rectangular form as well as polar form. All values you must find out, rectangular and polar. Similarly, same, the second current or line current, that is V2 by Z2, hence I3 equal to V3 by Z3. Okay, like that, you have to find out the different values. Okay, in the unbalanced system, all values are different, not equal. That's why you have to find out the every value individually. But in case of balanced system, all values are equal. That's why all magnitudes are equal, but the phase angle will be changes. That's why in balanced system, we have to find out the value only one time, and second value nothing but same value, but angle is different. Okay, in three phases, between the two phases, the phase angle difference is 120 degrees. That's why minus 120 minus 240, like that. We write down the phase angles also in case of balanced system. Okay, like that, in case of balanced and unbalanced system, we can derive the voltage and current relations. Okay, remember, in case of delta, line voltage equal to the phase voltage. Similarly, line current is equal to the root 3 times the phase currents. But in case of star, it is reverse. That is, line current equal to phase current. Line voltage equal to the root 3 times the phase voltage in case of star. Okay, both are reverse. Okay, na? These two formulas are very most important in case of gate examination problems also. Please subscribe our channel and share to your friends.